Okay, so here we have October, November 2010, paper 4, variant 2. Okay, this is a question here, the last question on the paper. It's about sequences, and it says, in all of the following sequences, after the first two terms, the rule is to add the previous two terms to find the next term. This is a special type of sequence called a Fibonacci sequence. Okay, so write down the next two terms in the sequence. So you see 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 13 is 21. Oops, make that a bit smaller. 8 plus 13 is 21, and 13 plus 21 is going to give you 34. Okay, so that's that sequence there. Then it says write down the first two terms of this sequence. Now, I know that this number plus 3 gives me 11, so of course this number must be 8. 8 plus 3 is 11. Okay, and 8 plus 3 is 11. And I know that the number before this must add to 8 to give me 3. Okay, so you can think of it like, all right, let's call it x if you're not sure. You can say x plus 8 has to give me 3. So x must be 3 minus 8. So x is negative 5. So you can think of it like that if you want, algebraically. So x is negative 5. Okay, something added to 8 gives me 3. It must be negative 5 because minus 5 plus 8 is 3. Then it says find the values of d and the values of e. So they're slowly getting slightly more kind of involved. So here we can see that if I add 2 plus d, I get e. So I can say 2 plus d will give me e. And I can also say that d plus e is going to give me 10. Okay, so we've basically formed a pair of simultaneous equations. If I rearrange this one here and I write it down, and I just write it as d minus e equals minus 2. Okay, I've just rearranged this equation written here, so you've got the d and e next to each other like this. So you can do simultaneous equations by elimination. Here, if we add these two together, we get 2d equals 8. So that means d is equal to 8 divided by 2, which is 4. So d is equal to 4, and we know that e is equal to 2 plus d. So that's 2 plus 4, which is 6. Okay, and you should always check to see if that makes sense. If I put a 6 here, as I put a 4 here and I put a 6 here, does that work? 2 plus 4 is 6, 4 plus 6 is 10. Yes, it does. So we can be sure that we're correct. Okay, now for part 2. This is question C, part 2. Find the value of x, the value of y, and the value of z. So now we are kind of juggling with 3 unknowns here. Okay, so it's slightly more complicated even still. So what we're going to do here is just use the same type of technique where we set up a few equations first. Well, we know that minus 33 plus x gives us y. So negative 33 plus x will give us y. We also, let's call that equation 1. We also know that x plus y is going to give us z. It's equation 2. And we know that y plus z is going to give us 18. That's equation number 3. So we've got to try to sort these equations out so you have just one unknown. Okay, so what you can think about here is I can imagine that this y here, for example, in this equation 2, I've got x plus y equals z. And here I've got minus 33 plus x equals y. And here I've got y plus z equals 18. So what I can do is I can see y is in all 3 of these equations. I've got y in equation 1, y in equation 2, y in equation 3. Alright, so if I take equation 1 and I make it such that x is the subject, then I can replace this x with something which has y in it. So to make x the subject here, I have to basically add 33 to both sides. So I have x equals y plus 33. See, this is I've got a little strategy here which I'm thinking about. I'm going to replace this x with y plus 33. Then I'll have y and y term. And then if I take this z in this equation 3 and I express it so it says z equals 18 minus y, just have to subtract y from both sides, I can take this z here and I can replace it with 18 minus y. So So if I take equation number 2 and I replace the x with y plus 33, instead of writing x, I'm going to write y plus 33. Okay, the y I'll leave it as it is because I want to have just one unknown. And the z, I'm going to write it as 18 minus y. Now we see we've got one equation with one unknown, which we can solve pretty easily. So here on this side I've got 2y, and that side I've got minus y, so you end up with 2y plus y. So I've added these y's together and I've added y to both sides. And on this side I've got 18. Whoops. This side I've got 18. 18, and I have to take away 33 from both sides to get rid of this 33. Okay, so I have 3y, okay, is equal to 18 minus 33. 18 minus 33 is minus 15. So I know that, therefore, y is equal to minus 15 over 3, which is negative 5. So I know that y is minus 5. Okay, so I know that this is now minus 5. Okay, so now I know I can now work out what x and z are either from using these equations. Okay, if I know y is minus 5, I can find x from here. I know that x is going to be minus 5 plus 33, which is 33 minus 5 is 28. So x is 28. So I know that this is 28, and we can now see if this works. Minus 33 plus 28 is minus 5. That's correct. And I know that z is 18 minus y, so z is going to be 18 minus y, and y is minus 5, so 18 minus minus 5, which is 18 plus 5, which is 23. So z is 23, and let's replace that with 23 and see if it works. Minus 5 plus 23 is 18. Yes, it works. So we can see that we've got this answer correct. Okay, so it's just a similar kind of pattern as the last one, except you've got 3 unknowns. So you have to try and find a way to express one of the equations with one unknown. So I looked to see what letter was common in all 3 of them, and then I used substitution to replace the other 2 letters with that letter from the other 2 equations. And there we solved that problem. I hope that was clear to you.